Hello, right now we're going to do some practice with my small angle formula that I just taught you. And if you just happen to come upon this video, I'm going to show you, here I'm going to put an annotation right there, and you can go see the video on this formula, because if you don't know what I'm talking about, you don't know the formula, you're going to have a hard time. So, okay, so just to go over, what we learned last time was d2 over d1 equals alpha. That's much better. So, how about we do a practice problem here? Oops, sorry. Let's see. Let's make a little diagram here with our little observer guy. Star. Planet. Okay. So, here. Oops. Here. Here. Okay, so let's say that this alpha here is 2 arc seconds. And how about this planet has a 5-year orbiting period? And how about this star has a mass of 2 solar masses? That's all we know, right there. This is what we need to do. And what we need to do is find the distance between the star and the planet. That's D2. My bad. Yeah, it's D2. Whoopsies. That's D2. And this is D1. So, how do we find this? Well, we don't have a formula that includes the mass of the star, the period, the orbiting period, and the angle at which we're looking. So, what do? We have a problem here because we don't have enough information. So, for this, we are going to try and find D1, the distance to the star, because it's, that's one of those things you have to figure out as an astronomer. So, okay, so we need, so it seems pretty simple, right? D2 over D1 equals 2. But we don't know what either D2 or D1 is. So what do? We go back to a cubed equals mp squared. Remember that? Yeah, from a couple of videos ago. And so what do we not know? We do not know A. A is an unknown. However, we know the mass. So we'll go to a cubed equals, the mass is 2 solar masses, so we'll put that 2. P is 5, so we'll do 5, and that squared. A cubed equals, no, that's 50. And here we go, cube root of 50. Now, I recently learned in my math class that if you square root something, that's the exact same as raising something to the half power. Cube rooting something is raising something to the third power. So 5 to the 1/3 power. Whoops. The 50 to the 1/3 power is 3.6 ... Actually, it's 3.68. So there we go. That's 3.7. Let's round it up to 4. So A equals 4 astronomical units. So, okay, let's make that, instead of distance 2, we now know that's 4. Okay, now for distance 1. Now it gets a lot easier. We have distance 1, we have distance 2, we don't have distance 1, we have distance 2, and we have our angle. So, back to D2 over D1 equals alpha. We have See, D2 is 4 over D1 equals 2. Okay, let's restart there. 4 over D1 equals 2. Is that right? That's what I wrote, right? 4 over D1 equals 2, that's correct, okay. So we'll do 4 equals 2D1. 2 equals D1. So, we now know the distance to that star is 2 parsecs, which is about 6 light years. So, there we go. That is our first problem. I guess got a bunch of spots on it, so we'll take that off as well. Okay, let's do a real-world problem. Let's take Kepler 22b, that awesome planet that we discovered that is an Earth-like planet, and it's really cool, because, yeah, it could harbor life, possibly. And I did a little research on my little machine, called a computer, and I learned that it is... First, let's make our diagram. That's Kepler 22b, that's Kepler 22, which is a star. It is 190 parsecs away. The orbiting period of Kepler 22b is 290 days, which is 0.8 years. And the mass of the star is 1 solar mass, which is very nice. So that's a lot like Earth, really. It's just as 190 parsecs away. So, what was our angle? And what is distance? And if you realize that that's almost 1, and since the star is about 1 solar mass, we can guess that's probably going to be about 1 AU. So let's find out. That's what I think. I think it's going to be around 1 AU. I haven't actually done this problem yet. So, let's do it. D2 over D1 equals alpha. D2 over 190 equals alpha. There we go. That's alpha for you. Whoop. See, so that we've got our little equation here, but don't have D2. So a cubed equals mp squared, but since m is 1, we don't care about that, so we'll do that. P squared, 0.8 squared, that is 0.64. A cubed equals 0.64. 0.64 to the 1/3 power is, ooh, yay. What do you know? A equals 0.86, which is approximately 0.9, which you can easily round up to 1. So there you go. Our hypothesis was in fact correct. That D2 is approximately 1 astronomical unit. And there you go. And yeah, there you go. We've done a real world problem. I will see you guys next video.